things are a lot more complex than one would assume that it will be. I mean, when we get fed up with load shedding, we say, I want off the grid completely. I just want to provide my own power. And it really isn't that simple, is it?
Indeed not.
Let me see if there are questions. Paul Vermeulen says, we are finding our medium voltage networks quite robust and able to evacuate quite a lot of power. We have approval over 80 megawatts and authorized more than 30 network studies for systems of 1 to 3 megawatt capacity without any negative impacts. Have you done studies on MV connected hosting capacity?
Okay, I can answer that. Thank you, Paul. My colleague, Justice Schuurter, he was with Trevor Gond at UCT previously, and he's very much the expert in hosting capacity on the medium voltage side. I think the challenge that he saw was more when the integration comes with your low voltage side. But it's so difficult to make a generalized statement about this, because as you would know, all the municipalities have different especially on a low voltage side, we don't actually know what the thickness of the cables and all the rest is. But I've not specifically done any studies on the MV side, so I'm not able to comment in detail on
that. Paul asks, how is Limpopo province comparable to Northern Cape or Eastern Cape in terms of grid connectivity for renewables?
I think it will have, let's go back to that graph. This GCCA study, this transmission generation connection capacity assessment, that is a study that is freely available on the internet. So you can, and they look at actually all the MTSs, they look at all the substations in that area. You see there's Limpopo. And they'll be able to tell you where the constraints are. What is nice about the assessment, they tell you where the problem is. Is it actually with the transformers, just upgrade the transformers, or do you need to have a new line, etc.? So that could give you more information. But you can see there's about 2.5 gigawatt in Limpopo waiting for your project. Let's see.
This balancing act that municipalities will have to do, how do you think municipalities are going to cope with that? There's certainly, there must be some computer IT assistance with that. Do you envisage that special systems will be developed for municipalities to conduct that balancing act ongoing 24/7?
Are you referring to the financial viability, or you?
Yes.
Yes. Okay. So that is so tariffs get approved. There's a formal process involving NERSA where municipal tariffs get approved, and that process allows for the municipalities to design their own tariffs. So this example here is these utilities 1, 2, and 3. They would have proposed and have been accepted by NERSA different tariff structures for their distributed generation customers or none. So yeah, so it's not a continuous balancing act. It's a yearly update of your tariffs to make sense. Does that make sense?
Oh, okay, all right. Yeah. And do municipalities do this individually? Would it be no? I mean, NERSA. How does NERSA do that? I mean, there won't be variations between municipalities.
Yes. No, there's massive variations between municipalities. How many municipalities? I think there's 200 and something municipalities. And yes, there's they're individuals, so they would be very different regimes. While I was still in the industry, one of the things we looked at in our marketing was we just built a tariff database of all the tariffs in South Africa, and then ran our simulations to see which places had the most viable or the most lucrative photovoltaic opportunities. And then you would specifically market to those customers. So let's say it's the small commercial tariff is very profitable in Cape Town, then all your marketing guys would try and sell PV panels to the small commercial tariff type people in Cape Town. Obviously, there's a big risk, especially if you start signing power purchase agreements that's 10 or 20 years. It might be that the municipality totally changed their tariff next year, and what was extremely viable to you as a customer now gives you a 21-year payback. So there's a lot of caveats if you're a solar installer to just make sure that your customer is aware of all the risks and pitfalls.
Right.
Yeah. And of course, what's happening now is we're moving towards a real-time energy market, at least on utility sort of scale. So which means there's a lot of very interesting things happening in terms of tariffs. But I think that the core message that I wanted to just share here is your utility and your customer are very much linked, or the financial viability of both are very much linked. If the one makes more money, the other one makes less money. And you need to find some sort of balance, which makes both of these entities sustainable.
Right.
Yeah.
Are you advising NERSA?
Am I advising? No. I'm just an academic. So all we do is we put these general sort of statements out and hope that someone listens or at least give feedback.
Okay. Yeah. All right. Just checking, we can ask NERSA to pay attention to it. It's actually, we invited NERSA to come and present, and they weren't available.
Okay.
So, but I think it might be worthwhile. Right. Here is another question from Skalk. Why would private producers make their inverters open to control if the public producers are not transparent in their sorry.
What do you mean about the public trans? Because but maybe I can.
Yes, I haven't finished reading. Can I continue?
Please, yeah.
Okay. If the public producers are not transparent in their cost structures, and there are massive inefficiencies and unsubstantiated costs, hence the costs of electrons may be much lower than the costs paid by consumers. Surely control needs to include transparency across the network. Skalk.
Okay, let me.
Engineering News.
Yeah. Okay, I think that's an interesting question. It has a few aspects to it. So let me first just define control or visibility and control at a technical level. What that means is, remember, a power system is instantaneous in the sense of the electrons. It's what you generate, you must consume immediately, except if you have a little bit of storage. It's not like a factory where you manufacture, I don't know, TVs or hose pipes or something. And you can manufacture a lot of them. And then if you have a big warehouse, you can just heap them up in a warehouse and they can be sold at a very different stage. So there's not a direct link between manufacturing and demand or use. In a power system, it's very different. Electricity needs to, once it's generated, be consumed immediately, or it must be stored somewhere. And we have very little storage. So based on this immediacy, a system operator, which is the role that Eskom fulfills, need to make very sure that at all stages your demand and supply is balanced. There can't be more demand and less supply. And that's what I mean by controllability. The first thing the system operator must be able to do is they must be able to see what is the current demand and what is the current generation. And then they must be able to control it by saying, okay, we take away some of this generation and we increase that a little bit. Okay, fire up your coal power station and cut some of your renewables, etc. Okay, so that's what I mean by visibility and control. I think what you are referring to in terms of non-transparency is more on the financial modeling side. So let's just finish the technical side. The technical side can be easily implemented through regulations, where you basically say, I am City Power, or I'm City of Cape Town, and you can only connect to my network if your inverter can be controlled according to this protocol or that protocol. So that's the technical side. From a transparency in costing structures, look, I'm of the opinion that we are actually getting amazing prices currently for our REAP, for our renewable energy, this program of ours. It's internationally renowned for the reason that it's really pushing down prices for these generators. I might have an issue with the way in which it's costing electricity at the moment, where it's still very much rand per kilowatt hour. All the contracts up to date puts the same value to a kilowatt hour that is produced by wind in the middle of the night and one that is produced at peak time. You know, you have a flat X cent per kilowatt hour rate, which incentivize renewable energy companies to go and put their turbines and plants where the most resource is, which is not necessarily what the grid wants. The grid might not want a lot of wind in the middle of the night. They want it during peak times. So there should be some sort of time of use or some sort of change in that sense. Okay, but that's a separate debate. But I think this tender process resulted towards the end in quite low prices. Sure, those first projects that were implemented through this program was extremely expensive, but you must also keep in mind at that stage there were a lot of risk. The banks were not willing to provide the financing. You know, that was the whole point of the program, to actually get the prices lower through creating a stable environment for these renewables.